Hi everybody, this is the Math 30-1 Trig 2 review. I was going to say that backwards. This is question 3b, and we're supposed to state the restrictions on the variables here. Remember that when we're talking restrictions on an identity, we got a couple places, or even expressions here, we got a couple places we got to look. The denominator can't be allowed to go to 0, but in addition we have to consider the functions tangent, cotangent, cosecant, and secant, because they each have their own set of non-permissibles that kind of come along with them. Now in this case, we don't have to worry about those, we only need to worry about the denominator. We cannot allow the denominator to go to 0. Okay, and that's cosine. Cosine can't be allowed to go to 0. Now 0 is one of those neat little ratios here that we typically associate with the quadrantal angles, okay? So what we might want to do here is take a quick look at the unit circle. As we go around the unit circle, okay, because this will give us the extreme values, or the values for cosine that are on those interesting angles there. So this is 1, 0, 0, 1, negative 1, 0, 0, negative 1. We associate the x-coordinate with cosine. I'm not allowing cosine to go to 0, so now I got to think, well, where does that occur? Well, that occurs up here at 90 and down here at 270, okay? So those are our restrictions. If cosine isn't allowed to be 0, then x cannot be allowed to be 90 degrees or 270 degrees. Okay. Now, those aren't the only two. Remember, cosine is a periodic function. It repeats, and it repeats every 360 degrees. So 90 degrees or 270 plus n times 360, where n is an element of the integers. And again, I'm going to use this, whoops, sorry, you can't see that. I'm going to use a z to represent integers because that's what you're going to see when you get to university. That's the common symbol for that, okay? I know that we will typically allow I, but z's the correct symbol there. Now, some of your instructors might insist that you go take this a little further here. Because our angles here, our restrictions here are 90 and 270, there's actually a more efficient way to write this. Notice that 90 and 270 differ by 180 degrees. So, and that's a repetitive pattern. Every time I go 180 degrees, I'm going to be bouncing back and forth between those two. So, I can actually make this a little bit clearer by saying, okay, x can't equal 90 plus n times 180, where n is an element of the integers. And that will take that relationship between those two angles into account. And that's just a slightly more efficient way of writing that answer.